So as we transition to the lightning round talks, I thought we'd have a quick moment for audience participation and keep the creative juices flowing. So this is a quiz primarily for the hard rock geologists and the remote sensors out there. I took the liberty of grabbing this screenshot and blurring the image a little bit, but essentially the scale is about 2 meters side to side. And this was taken on a planetary surface. And if anybody knows what this is an image of, the first beer is on me during the poster session.
I got it.
Yeah?
Snowstorm in South Bend.
Nope. Anyone else? This is a shot of the inside of Clive Neal's closet.
I'm in green today.
And I think we can all agree that Clive has had a large impact on the next generation, but I think as you can see here in the Clive Neal lab group picture, he's having a little too much of an impact on the next generation. So, yeah. Yeah, he did. No, he's standard as normal. Okay, all right, so now we're on to the lightning rounds. We have fostered the lightning round talks as part of the Exploration Science Forum. It's an opportunity for poster presenters to stand in front of plenary and sell their posters, get you to come talk to them during the poster sessions, et cetera. Hopefully this will also lead into the poster discussion that we'll be having at 5:30 later this afternoon. And so this is the list of poster presenters that will come talk to you. If your name's on this list, please go ahead and start making your way this way as soon as the person in front of you starts giving their talk. They do have 2 minutes, no slides, and no questions. If you do have questions for them, I encourage you to hunt them down during the poster session or, in Brian's case, in the checks room right behind us. At 30 seconds left in your 2 minutes, I'll kind of wave at you, and at 2 minutes or 30 seconds after that, I'll probably come stand right next to you, so you'd be very uncomfortable. Okay, we'll get started with Brian.
I'm glad I woke up in time to be surprised by seeing my name up there. So in the past year, for any of you who don't know it, we retired the venerable LMMP, Lunar Mapping and Modeling Portal. It has been replaced by a new portal with superior visualization capabilities. We're adding a lot to it. We've got brand new data products that we're adding right now, including the global mineralogy from the Kaguya Spectral Profiler from Paul Lucy, Miriam Lemelin's polar mineralogy, Matt Siegler's ice stability at depth, a lot of resource prospector, many, many, many things. If you have ideas of data products that you would like to see included, please come talk to us. In addition, we are adding a suite of new analytical tools. So, for instance, we are working with Bill Farrell and are just wrapping up on the user interface for his excuse me, I had a concussion this past week and I haven't quite shaken it. The surface potential analysis. So what we're actually able to do is measure and model surface potential. So if you have tools, if you have algorithms that you would like to have hosted, so not just data products, but if you have algorithms that you would like to have us host, we would very much like to talk to you about that. A lot of new possibilities coming up. And one final thing, we have 3D visualization. We're now expanding that to 4D with time series. So you'll be able to see that, for instance, with diviner temperature varying over time. So, oh, and finally, VR. And the goggles are a bold fashion statement. Thank you very much.
Hi, my name is Eric. I'm an engineer from Astrobotic, and my poster is on Astrobotic's terrain relative navigation solution for precision landing and a status updates with that. So firstly, terrain relative navigation is the technique of using stored onboard maps and optical feature matching to precisely locate your spacecraft during power descent. As we heard from talks before, precision landing is hugely necessary for some missions targeting the poles, skylights, pits, sample return missions, et cetera, et cetera. It's still state-of-the-art technology. JPL has their own solution for TRN for Mars 2020. And Astrobotic's interested in lunar TRN for our own Peregrine lander missions, as well as other low-cost lunar lander missions. So the poster presents some results where we have our TRN hardware is basically a camera and independent commuting in a box in a chassis, and we've demonstrated it to TRL6 on a flight opportunities contract with Maston, where we demonstrated TRN terrestrially and in real time. Since then, we've been focusing on the lunar portion of that, where how do you generate the lunar maps. We have our own simulation framework where we synthetically light topography products to produce the maps that match the exact illumination conditions, or hopefully near, that the spacecraft will observe, and it performs TIR in that way. So we're interested in talking with any of your mission concepts that require precision landing and the challenges of that, and we're also interested in experts in the topography products, as we rely on them very heavily, as there's many idiosyncrasies with all those topography products. Any of those topics, we'd love to talk with you. Thank you.
So poster 26 is actually under Mark Shirley's name, but he's away just for the moment. It's a poster that's devoted to actually hands-on traverse planning for resource prospector. It basically gives you the flavor for what is required to actually plan and carry out and execute a traverse at the poles of the moon for a particular site that we were using as a reference site, Hermite A. And the tool includes a wide variety of map layers that come in to constrain what you can and can't do in a traverse. So for instance, it incorporates slopes, other terrain features. Most importantly of all, it incorporates Matt Siegler's depth to ice stability, which we use to design stops, locations where we go to drill and excavate samples and evaluate the occurrence or non-occurrence of water ice or other volatiles at these locations. And we have certain requirements set for a number of these locations of various depths, separated by certain distances, like Tony talked about the other day. And that's all buried inside this tool. And one of the best things of all about the tool is you can run it, and it can operate automatically to generate literally thousands of traverses. Some of them are very similar, but they're variations on a theme that allow you to actually show how robust a given traverse area, a given area that you want to explore for the resource question actually is. And so I encourage you to come by poster 26. You'll see a real-time demonstration of the planning tool. Mark will let you do your own traverse plan in the Hermite A area. And it's very interesting. And it turns out that, guess what? You go slower than you think you can. No 20 kilometers per hour. But Lunicod 2 kind of speed made good of the order of a centimeter a second. It turns out you can accomplish the mission with that kind of a speed and achieve all the requirements robustly. So come on by poster 26.
Hi, Sharon Kedar, JPL. One of the first things Apollo 11 astronauts did was place a seismometer on the surface of the moon, as did pretty much every other Apollo missions and the Viking missions. The last Apollo sensor was turned off in September of 1977, 40 years ago. And since then, in spite of at least 5 successful landings on Mars, we have not placed a seismometer outside Earth. That is going to change with the InSight mission that is going to launch and land in November of this year. And I hope and believe that it will usher a new era of seismic exploration of our solar system. Now, there is a consensus in this room that the Lunar Geophysical Network is a necessity, and it is on the New Frontiers 5 portfolio, at least according to the current decadal survey. However, what a lot of people don't realize is that the seismometer required by the Lunar Geophysical Network is about 10 times has 10 times the performance of the current state of the art, and it's not in existence. And while we are developing it, thanks to some NASA funding, and come to talk to us about that too at poster 18, I firmly believe we need not wait for the perfect seismometer or the perfect network to get valuable geophysical data from the moon and elsewhere. So as Clive pointed out, one of the game changers is commercial landers. Another game changer is modern, existing, and rapidly emerging seismometer technologies. And we can combine those to start chipping away into lunar geophysical network objectives, inform future LGN mission. So if you'd like to talk to us about that, about the trade and balance between network distribution and placement, mission duration, and seismometer capabilities to most efficiently inform future LGN mission, come talk to us, poster 18.
Hi, I'm Carsten Becker from PT Scientists. We're a company transporting or offering lunar transportation services and communication services. So we play the lunar landing game in hard mode because we are from Europe. We don't have Silicon Valley and all the billionaires. But we are very good at tying in other industry partners. For example, we are collaborating with Audi. So without a doubt, I guess we have the most sexiest rover alive. And soon on the moon. It was a top speed of 3.6 kilometers per hour. It's not really Audi style. But it does have, it was also featured in the new Alien Covenant movie. So you might want to take a look at that and how we helped the crew to die more slowly. And anyhow, we also, our name is PT Scientist. That means we have some science in our name. And we're very interested in doing some science with you. And one of the simple experiments, which essentially costs nothing that we are taking with us, is a shear force test of the gravity soil, where we are turning the wheels and measuring how much force there is coming from, how much energy is needed to turn the wheels. Also, we have 3 cameras. So the middle one is a telelens with a filter wheel in front of it. We have 9 slots. And from those 9 slots, we are already using 3. And we have no idea what to put into the 6 others. So please forward us some ideas on what to do that. And as I said, we are also in the communication service industry. So we are bringing an LTE base station. That is what you're using to communicate with your mobile phones with us to the surface of the moon. And we are helping you to enable new future missions by lowering the cost and providing communication infrastructure and navigation for your future missions. And if you have any questions about that, feel free to contact me. Rolf and I are walking around, and we also have some roll-up in the post area. Thanks.
Hi there, good afternoon. My name is Alexander Van Dyke. I don't have a poster, but I have a booth. I'm associated with the program that has a booth out there called Flight Opportunities. It's one of the programs within the Space Technology Mission Directorate. And we have been at this sort of confluence of commercial and science or technology for quite some years. We've been working on this program for 7 years. We work with some of the companies that are represented here, like Maston is here. So I'm very pleased to see that commercial and lunar science is sort of coming together. What my question is to you is I'm interested to see how we can leverage what we've built with the suborbital flight testing program for the lunar science. So I'm scratching my head a little bit, beyond the 1.6 on a parabolic flight maybe, but would balloon flights be of use for your technology demonstration or your science testing? We fly with Blue Origin. There's a brochure. We have a couple of companies on, I'll just name them here. We have Virgin, Up Aerospace, and Blue Origin as our flight providers on the suborbital realm. We have 2 balloon companies, Worldview and Near Space Corporation, and we also work with Zero Gravity Corporation, the parabolic flight provider. So I'm very interested to learn more about how we can help you get your science to the moon. So if you have some thoughts on this, please come see me at the booth or come grab me when we have a social hour or something. Thank you very much.
Hi, I'm Martin Elvis, Harvard-Smithsonian. I'm an astronomer and definitely not a lunar scientist. But we've heard over the last day and a half or so a large and fascinating variety of possible lunar landing sites, wide variety. But what struck me, not only here but before, is that the actual area of some of these most interesting sites is remarkably limited. And that means with the very large number of players about to go to the moon in the next 5 years or more or so, that there could be conflict between those players about which site to go to. If we all want to go to one site, it ain't going to happen. Even if you restrict this to science, this is a problem. Because, for instance, if you land in the middle of one of these small landing sites, you effectively preclude people landing anywhere near you, because that would be destroying. They have a chance of destroying your research station, which is prohibited under the Outer Space Treaty. Once commercial actors get into the game and the real resources are worth something on the moon, and it's not just science anymore, you can bet that the scientists are not going to be the ones making the decisions about who lands where. And the problem is, there is no one who has that responsibility. This has to be an international collaborative work. It's best if the scientists begin it, in my opinion, but we should really do that. Perhaps there are such efforts going on. Jim may know about those. But it's going to get a lot worse once resources are involved. So my poster, which is number 10, goes on about this at some length and gives some examples. Thanks.
Apologies to Penny Boston.
Yes, I'm not a boson, I'm actually a baryon. Just call me Higgs. So I came as an ambassador from the world of astrobiology, and you may think that astrobiology does not have a lot to do with the moon, but au contraire. It's a wonderful test bed for studying some of the gravitational aspects that we would expect to see organisms exhibit on bodies with lower gravitational constants. But what I really came to share with folks is my passion for the subsurface, and I was delighted, of course, when we started to actually see big pit craters in image data from the moon. And for many years, I've been working on the issue of lava tube caves and, in fact, other cave types on Mars from the astrobiology point of view. But I'm as much a geologist as a biologist, and so the lunar opportunity to actually observe the moon from beneath the surface is extremely tantalizing. And my motto is, she who only understands geology in outcrop is just scratching the surface. So I think ultimately the subsurface destination on the moon is a very important one in order to give us, as Laura Kerber pointed out earlier, the ability to see the sequencing of lava and perhaps intervals of weathering and so forth. These are invaluable. So the science part of it, there is a huge case to be made for that, including the potential for putting even non-geological monitoring equipment in a much more protected environment and leaving it there for significant periods of time. The other aspect of the science, of course, is using those facilities in the human context, and that brings us to shelter. We've done a lot of work, been funded by NIAC in the early to mid 2000s to actually look at the issue of shelter within natural cave structures on Mars and the moon. We did a lot of work on that, and that's all in the literature if you're interested. And then lastly, of course, there may be the potential for stuff that is different from what is exposed on the surface. Obviously, in a non-aqueously dominated body like the moon, this is going to have a very different character, but we don't know what that is. And so there is much potential for this subsurface terrain. And the poster's out there, but I won't be, but I'm going to leave it there. And if you want to know about caves, then contact me. I'm here at NASA Ames. Thanks.
Hi there, I'm Kieran Carroll. I'm from JetX, a company up in Canada near Toronto. We're a gravity geophysics exploration company, mostly terrestrial, but getting into space exploration as well, gravity exploration in particular. And I've brought a prop with me today, which is an engineering model of a new space gravimeter that we are developing that's pretty close to flight now. And we're looking at using that for missions on the surface of the moon and on asteroids, maybe someday on Mars, although those missions are few and far between and highly competed, so I don't know about that. But the Canadian Space Agency is helping support us financially in developing this. I fully expect that the CSA will be willing to contribute these instruments to international missions at zero cost. So my poster talks about some of the science applications, science investigations that we've identified so far that you could do on the lunar surface using this sort of an instrument. There's only been one gravimetry investigation done off Earth prior to now. That was in Apollo 17. It was Jack Schmitt and Gene Cernan did that. And that instrument's long gone and obsolete, but we're bringing that capability back to life again. So I'm at poster number 5. I'd be happy to talk to any of you about, I'm interested to know if any of you have thoughts about gravity investigations that could go along with the sort of investigations you're thinking of right now. You know, this wants to go on a rover so that you can make multiple measurements in some area. And you're thinking of some measurements already, perhaps gravity measurements could augment those. So come talk to me at poster number 5 if you want to talk about that or if you want to see the gravimeter. Thanks a lot.
Well, I'm Sam Jimenez, and I represent an international consortium of research universities and research institutions from Canada, the United States, Australia, UK. And we are looking at the Marius Hills pit. Our poster is about the third leg of the stool, from science, exploration, and then habitation. How do you get there? And how do we use the foundations of science and exploration to build on the habitable areas of these lunar pits? And in particular, the Marius Hills pit, we think that's the one to start with. It actually can be a prototype for how to utilize these sites. We found 200 or so, 300 already on the moon and on Mars. And these, the access to these pits are problematic, they're deep. The Marius Hills pit is probably, in our viewpoint, the best one to start with. Of the 3, Ingeni, Tranquillitatis, and Marius Hills, it's the smallest of them, but still large enough to start thinking about it in terms of the utilization of it for habitation and settlement. The idea then there is to get out of the cans, get out of the spacesuit, start maybe utilizing that volume for a longer term colony, lunar base, and how you do that. So the poster number 29 talks about the construction aspect. How do you begin the construction sequence? How do you get down there with some concepts for access to the bottom of the pit? And also we have some instruments that we're looking at now in the science phase. So we begin with the science phase, we're looking at that, we don't go straight to the architecture. And then the exploration phase, which is the human part of it. How do you get humans down into the pits? And then finally, the construction phase. We're working with additive construction technologies using the regolith for the 3D printing of foundations and the surface systems. Around these pits, you'll probably have as much infrastructure on the top of the pit, on the surface, as you will on the bottom, in terms of spaceports and, landing pads and the support structure for whatever activity you're going to be doing there eventually after the science is done. We have a green reconnaissance approach in the beginning. We want to keep the site pristine for the scientists when we first approach these pits, and our traverses have to take that into account with the design of the instruments. We want to be able to land far enough away so that you don't disturb the pristine nature of the site at the beginning, and that impacts the design of your instruments and how you get the instrument deployed into the pit as well. So that's where our starting point is, designing those instruments and those access, and the access to the instruments into the pits as well. And then we go into the human reconnaissance phase. How to get humans down there? We start relaxing the green reconnaissance protocols by the time you start exploiting the pit and start talking about the construction. So we're at poster number 29. We're glad to talk to you more about it. Thank you very much.
I believe that concludes the lightning round talk, and I think we're up for a break now. And what time are we getting started, Greg? 3:50, so a little less than 10 minutes. And enjoy your time.